All right, guys, here we go. Section 2.2, basic differentiation rules and rates of change. So this is a happy day for you guys, a very happy day for you guys, because we learned the shortcuts. And the shortcuts are shortcuts, okay? You're gonna say, why did they ever do it the long way? I don't know. But when you go to college, you're gonna have some people who make you do everything the long way. That makes no sense to me, okay? But hey, those professors are a lot smarter than I am. It doesn't even matter what school you go to. I've had students at UMass in the same hallway. One professor lets them use the calculator and shortcuts, one makes them do everything all out. So I show you both, you're prepared for both, and then whatever happens next year, you can handle. So the first one's called the constant rule. And the constant rule is when you take, that's just notation for a derivative, okay? When you take the derivative of a constant term, your answer is 0. And I guess I should do it with a letter. Okay, we'll say C is a constant, 0. The derivative of 5 is 0. The derivative of 1 is 0. The derivative of 129 is 0. Okay? So if I said f of x equals 6, then f prime of x would be 0. If I said, let's use some other notation. If I said that y equals 7, then y prime equals 0. If I said that y equals 3, then dy dx equals 0. This, again, is just notation for the derivative. Then we have this one. This is going to be the one that's life-changing for you, okay? It's called the power rule. And the power rule says the derivative of a term with an exponent, we take the n, we multiply times the base, and then we subtract 1 from our exponent, okay? So if I had f of x equals 3x squared, we used to put x plus delta x in there, we would square it and all that stuff. Well, here it is. Here it is, my derivative. You take the exponent, multiply here, 2 times 3 is 6. My base stays the same, subtract 1 from the exponent. So if I had this, y equals, I don't know, 10x to the 5th. Boy, that'd be a bear to do if we had to do it out. But with the power rule, 5 times 10 is 50x. Subtract 1 from your exponent, 50x to the 4th. So if I had this, g of x equals x to the 1/3 power. Well, and we're going to see a lot of fractional exponents, so it's something you got to get ready for. The derivative would be g prime of x, 1/3 times x, 1/3 times x, subtract 1 from the exponent. 1/3 minus 3/3 is going to be a negative 2/3. And there's your derivative. Okay? And I guess I could rewrite that too, right? I could say 1 over 3x to the 2/3. Sometimes they want you to do that, sometimes they don't care. Let's say I had this, okay, here's a good one. Y equals 1 over x squared. Now, when we have fractions, there's a special rule for how we do fractions, okay? So, we're not there yet. We're going to do that in section 2.3. So if you have one like this, we have to rewrite it. We have to rewrite it so it's not a fraction. So I'm going to write this as x to the negative 2. Now all I did was rewrite it, okay? I didn't do anything there, I just rewrote it. So now I would do negative 2 times x, subtract 1 from my exponent, and I could also write that as negative 2 over x cubed. Okay? All right, so the next thing, I'm going to talk more about slope. Slope is the derivative. The slope at a point is the value of the derivative at that x value. finding the slope of a graph. We're going to say find the slope of the graph of f of x equals x to the fourth when x equals -1, x equals 0, and x equals 1. Okay, so let's just look at what that graph would look like. Y equals x to the fourth is kind of like y equals x squared. It really is, except the bottom of it is not as narrow, it's a little bit wider. So it would look something like this. Okay, just a little bit wider. So what we're doing here is we're finding the slope of this curve at x equals -1, so maybe here, at x equals 0, which would be here, and then at x equals 1, which would be here. So we're finding the slope of those tangent lines. That's what we're doing, okay, if we want to tie it to what we did in section 2.1. So let's first find the value of the derivative. So the value of the derivative, or the formula, I should say, for the derivative would be 4x cubed. Now I plug in a -1, so I'm going to have 4 times -1 cubed, which is -4. So that's what the slope of that tangent line is, -4. Makes sense, it's negative, right? Negative slope. 0. Plug a 0 in here. What do I get? 0. Okay, 0. Makes sense, right? Horizontal tangent line, slope is 0. Makes sense? Come on, little connection there. X equals 1. Plug a 1 in. 4 times 1 cubed. 1 cubed is 1, times 4 is 4. Makes sense. Okay, positive slope, positive 4. Now, let's go to the next step. Let's go to the next step of that type of problem. Find an equation of the tangent line. Find an equation of the tangent line to the graph of f of x equals x squared when x equals 1. Oh, no, sorry. X equals -2. I'm going to keep it consistent with what I have in my notes, because I must have created a problem like that for a reason. Let me just check and see how much battery time I have. A little bit. So, find an equation of the tangent line. Well, I got to find the derivative here. Okay, I'm going to find the derivative. So my derivative, f prime of x, is going to be 2x when x equals -2. This is a formula for the slope. Okay, so what I need to do is plug in the x value. So you plug in the x value, and I say 2 times -2, and that's -4. So my slope is a -4. Now I have an x value, but I don't have a y. So when they just give you an x value, you take the x value, you plug it into your original equation, okay? And that would tell you what your y is, right? So my ordered pair here would be -2 squared is 4. So that's my x, that's my y. So, that's my y. So I do y equals mx plus b. My y is 4. My slope is -4 times -2 plus b. 4 equals 8 plus b. -8 minus 8, b is a -4. So here is my equation. Y equals -4x minus 4. Okay? Just like New York, man. Just like New York. All right. Let's do some more derivatives. More derivatives. You guys don't mind doing derivatives now. With a shortcut, it's easy, right? No complaining, Patrizzi. No complaining. All right, so we're going to take the derivative of say we had a polynomial, f of x plus g of x. You had a couple of different functions added together, or subtracted, or whatever. You take the derivative of the first, and just add it to the derivative of the second. Okay, so, let's say I had this. I don't know why I put this problem here, but y equals 3 times x minus 1, x plus 1 cubed. So we can't, there's going to be a shortcut to this called the chain rule that we'll do in 2-4, but for now, we have to multiply that out, okay? And this, you can multiply it out using the binomial theorem. I don't know if I've showed that to you by now in this video or not. So, I hope I did, okay? You can just multiply, the long way, it would be x plus 1 times x plus 1 times x plus 1, okay? The binomial theorem, which I hope I already showed you, but if not, here's a little preview. This is 3, okay? So I do 3, 0, 3, 1, 3, 2, 3, 3. And you're like, what's that? What is that? Take this term cubed, and then go down by 1. X to the 0. Take this term cubed, and go up, go this way. So this is 1, this is 3, this is 3, this is 1. So I'm going to have x cubed plus 3x squared plus 3x plus 1. And then I have a multiplied by 3. So it's going to be y equals 3x cubed plus 9x squared plus 9x plus 3. And you say, wow, I'm done. No, I didn't find the derivative yet. Okay? All I did was multiply that out. I expanded it. Expanded it. A binomial expansion. Binomial, two terms, binomial. Expansion. So, now I find the derivative. Well, that's going to be 9x squared plus 18x plus 9, and the derivative of 3 is 0, so there's my derivative. It is a beautiful thing. Let's look at some more. Let's say I had this. X equals root x plus the cube root of x. Well, when I see these, what I do is I take them and change them into fractional exponents. So this would be x to the 1/2 plus x to the 1/3. And again, I didn't do anything yet. All I did was rewrite them. Now I have to do the work. Now I have to find the derivative. This is going to be, the derivative is 1/2 x, subtract 2/2. So it's to the negative 1/2 plus 1/3 x, subtract 1, so you're subtracting 3/3. So I get negative 2/3. If I wanted to rewrite those, I could write it as 1/2 root x plus 1/3 times the cube root of x squared if I wanted to. Sometimes you can leave it like that. You'll figure that out as we go along. Good stuff, man. Good stuff. Good stuff. So, let's look at a couple more. And then we can talk about trig functions. And you like the trig functions for this, but it's easy. F of x equals x squared plus 3x cubed plus 4x plus 2, all divided by 5x. Well, I think I told you that we can't do these with fractions yet. We're going to learn how to do fractions with this in section 3-4. And you don't want to go there yet. Or 2-3-4. 2-3. Okay? Be happy with what we're doing. Be happy with these little shortcuts and these little simple little rules, because it is going to get harder. Okay? It is. So enjoy it. Enjoy our time here. Don't try to jump ahead. So because I can't do fractions, I have to take this and I have to separate. Okay? Separate. X squared over 5x plus 3x cubed over 5x plus 4x over 5x plus 2 over 5x. And then I've got to rewrite these so we don't have fractions. So this one would be 1/5 x squared divided by x, 1/5 x, plus 3/5 x cubed divided by x is x squared. And then this is just going to be 4/5 because my x's cancel. And this is going to be 2/5 x to the -1 because we can't have fractions, okay? So we have to utilize these negative exponents. So now that, again, I didn't do anything yet. All I did was rewrite it. Now I've got to find the derivative. The derivative of this is 1/5. We go here. 2 times 3/5. That's going to be 6/5 x. Subtract 1 from your exponent, 6/5 x. Derivative of a constant term is 0. Negative 2/5 x. Subtract 1 to the -2. All right. Now, we're starting to get some that looks like big boys and big girl problems, okay? Calculus problems, right? Look at something like that. 4 times, that's supposed to be the 4th, okay? So I guess what I want you to do, I want to see how much you can do this by yourself. So what I want you to do is I want you to try to rewrite that. Think about what we did in on those worksheets that we did, okay? By now we will have done those worksheets, which kind of give us an introduction to this stuff and doing some big time simplifying. You know, I'm not going to make any excuses. It's an honors class. It's one of the highest math classes we offer here. So we're going to have some tough stuff. So please pause the video and just hit pause for a second and try to rewrite those. Because if you're just sitting there listening to me writing stuff down, you're not going to learn it to the same degree. So I hope you listened. I hope you paused the video. So x to the 1/2, that's what the root x is. So if I have x squared times x to the 1/2, I add my exponents, I get 2.5. You can't have a mixed number as an exponent. 2.5 is 5/2, so I'm going to make that x to the 5/2 minus, I guess there's nothing there. This one is already rewritten. And this one's going to be minus 4x to the 1/4. So, again, pause the video and find the derivative. Okay, so I hope you paused the video. 5/2 times x is 5/2 x. Subtract 1 minus 2 over 2 gives me 3/2. 2/5 times 3. That's going to be negative 6/5 x. Minus 5 over 5 gives me a negative 3/5. And then here, 1/4 times 4 is 1, so it's negative 1. X subtract 4 over 4, negative 3/4. How about that? How about that? So here's one for you guys to try. So y equals 3x minus 4 times 2x squared plus 6. You can't take the derivative of the first parenthesis and multiply times the second. For right now, the only way that we know how to do this is you have to FOIL that out. Okay? FOIL that out and then find the derivative. So please, pause your video and do that. So I hope you listened. I do. I hope you listened. Pause that video. So we're going to have y prime. Well, no, I'm sorry, not y prime yet. Let's FOIL those out. So 3x times 2x squared is going to be 6x cubed minus 8x squared